Mars. No other planet captures the human imagination as Mars does. The reason is the striking similarity between Earth and Mars in many respects. Compared to the extremely hostile conditions on other planets, Mars, with its familiar surface features like hills, valleys, highlands, and plains, polar ice caps, its relatively benign surface temperatures, and its day, which is a little longer than an Earth day, has made humans gaze at it with curiosity and excitement. For centuries, humans have observed Mars as a red dot in the night sky, moving slowly against a background of fixed stars. Because of its red color, ancient Romans named the planet Mars after their god of war. People of ancient India named it Mangala, and the same name has remained in many Indian languages today. It is also known as son of Prithvi, Mother Earth. Systematic telescopic observation of Mars began in the early 17th century with Galileo Galilei's observation, which resulted in the discovery of many interesting things and optical illusions associated with the observations, giving rise to certain misconceptions. Prominent amongst them was the belief that Mars was the abode of intelligent life capable of building gigantic canals. This firm notion in the human psyche led to dozens of robotic spacecraft, including the Mariner 9, the Viking, and the Mars Express being sent to explore the planet after the dawn of the space age. However, not one of these robotic investigators has revealed the existence of even microorganisms on Mars, let alone intelligent creatures with superhuman capabilities. Nevertheless, Mars has not revealed all its secrets. Today, there are many fundamental and profound questions about Mars that are yet to be answered. Prominent among them are those related to the evolution of Mars and its suitability for the origin and sustenance of life in the past, or the viability of microscopic life today. Thus, there is a continuous and concerted effort across the globe to explore the planet by sending orbiter spacecraft to Mars or putting landers and rovers on its surface. India's Mars Orbiter mission is an essential part of this global effort to understand Mars in more detail. India is a prominent spacefaring nation today. Besides building and launching a variety of Earth-orbiting satellites for rapid and all-round development of the country, the Indian Space Research Organization, ISRO, has now set its sights firmly on Mars and has endeavored to realize the Mars Orbiter mission. The Mars Orbiter mission envisages sending an unmanned spacecraft to Mars and putting it into an orbit around the planet, conducting modest yet meaningful exploration of its surface, atmosphere, and the space environment in its vicinity through the spacecraft is the main scientific objective of the Mars Orbiter mission. However, the primary goal of the mission is mainly technological and aims to demonstrate the technological capability of India to send a spacecraft to orbit around the red planet. The Mars Orbiter mission spacecraft is shaped like a cuboid and weighs 1,340 kgs at launch. Special alloys and composite materials have been used to build the skeletal structure of the spacecraft. Its inside temperature will be kept within safe operating limits using a host of materials, including a bright golden-colored multi-layer insulation blanket. The 3 solar panels projecting from one of its sides of the Mars Orbiter mission spacecraft generate about 800 watts of electric power near Mars. The 2.2-meter diameter dish-shaped antenna projecting from the other side of the spacecraft facilitates the spacecraft's radio communication with the Earth. In addition, It enables the accurate measurement of the distance between the spacecraft and the Earth. A variety of sun and star sensors, along with gyroscopes, enable the precise determination of the spacecraft orientation, which is very critical during different phases of the mission. The microprocessor-based control system of the spacecraft acts as its electronic brain and very accurately maintains or changes its orientation and orbit. For this, it relies on the spacecraft's reaction wheels and small rocket engines called thrusters, as well as the spacecraft's main rocket engine called the liquid apogee motor. To study the surface of planet Mars and its atmosphere, as well as the space environment near the planet, the Mars Orbiter mission spacecraft carries 5 scientific instruments which are usually referred to as payloads. They include cameras and spectrometers and together weigh about 15 kilograms. The Mars color camera of the spacecraft is designed to take color pictures of the surface of Mars and its 2 natural satellites, Phobos and Deimos. It helps in studying various Martian surface phenomena. The Thermal Infrared Imaging Spectrometer payload helps in the identification of Martian minerals. The methane sensor for Mars is intended for very accurately measuring methane in the Martian atmosphere and mapping its sources. Since methane is produced as a product of both biological and non-biological activities, detection of methane and knowledge of the activity responsible for its origin becomes crucial. Of the 2 other payloads, the Lyman alpha photometer helps in understanding the processes responsible for the loss of water from the Martian atmosphere. Finally, the Mars Exospheric Neutral Composition Analyzer MENCA payload will study the space environment around Mars. The precious scientific data gathered by the spacecraft's payloads will be transmitted to Earth through its 2.2-meter dish antenna. The incredibly weak radio signals whispered by the Mars Orbiter mission spacecraft will be received by the antennas of the Indian Deep Space Network at Bailalu near Bangalore. The Indian Space Science Data Center, ISSDC, also located at Bailalu, will receive, organize, process and systematically store and distribute the scientific data gathered by the payloads of the spacecraft. Other ground stations located around the world will support the Mars Orbiter mission at specific times. The journey of the Mars Orbiter mission spacecraft to the Red Planet is a challenging as well as an exciting one indeed. The launch window, the interval of time during which the spacecraft can be efficiently launched to Mars in 2013, extends from October 28th to November 19th. The first phase of the spacecraft's journey will begin with its launch on board the uprated or XL version of India's workhorse launch vehicle, PSLV. The mission to launch India's first Mars spacecraft happens to be the 25th launch of the versatile and well-proven PSLV and is designated as PSLV C-25. The launch is scheduled to take place from the first launch pad at the Satish Dhawan Space Center at Sriharikota, the spaceport of India. After its liftoff, it will take about 42 minutes for PSLV C-25 to place the Mars Orbiter mission spacecraft into an elliptical orbit around the Earth. For the first time, ship-borne ground station terminals stationed in the Pacific Ocean will be used to monitor the performance of the PSLV's 4th stage, as well as the separation of the Mars Orbiter mission spacecraft from that stage. This parking orbit extends 250 kilometers on one side and 23,500 kilometers on the other side from the surface of the Earth. Later, the liquid apogee motor LAM, which is the main rocket engine of Mars Orbiter mission spacecraft, will be repeatedly fired to ultimately make the spacecraft follow a path to encounter Mars by September 2014 in its orbit. During its 300-day journey to Mars, the spacecraft will leave Earth's sphere of influence when it will move beyond 1 million kilometers from Earth. Then it will travel in a curved path, mostly under the influence of the Sun. Finally, when the spacecraft is about 500,000 kilometers from Mars, it will come under the sphere of influence of Mars. As the spacecraft nears Mars after its 10-month-long journey, lasting millions of kilometers from Earth, its LAM will be fired again. This time, it will be to sufficiently slow down the spacecraft to enable it to be captured by Mars in an orbit around it. Once safely in an orbit around Mars, an intense observation of the red planet using its scientific payloads will begin. Besides the formidable challenges associated with the safe navigation of the spacecraft to Mars with minimum energy expenditure, many other daunting challenges confronted ISRO scientists at the time of building India's Mars spacecraft. Prominent among them were issues related to the radiation-intense environment in which the spacecraft has to operate during its lifetime, and wide temperature variations which it has to tolerate. Another challenge was the reduction in the power generation capability of its solar panels due to low solar illumination near Mars, as the red planet lies much further away from the Sun. In addition, the critical role of the spacecraft propulsion system, consisting of thrusters and LAM, made them to take additional measures to enhance its reliability. Nevertheless, based on their past experience, they confidently met those challenges and built the Mars Orbiter spacecraft in a record time of about a year. The result? India's trusted launch vehicle PSLV triumphantly waits to launch the spacecraft as the world watches. One of the prominent features of India's first Mars spacecraft is its ability to autonomously assess its health and take suitable actions at certain times to rectify problems on its own. This has been incorporated into the spacecraft due to the long communication delay time of up to a maximum of 42 minutes due to the enormous distances separating Earth and Mars. Thus, ISRO has persevered to meet the daunting task of building a state-of-the-art planetary spacecraft in an extremely limited time. As the launch time nears, like many of their countrymen, thousands of ISRO scientists who have toiled for the Mars Orbiter mission are filled with excitement and wait with bated breath for India's maiden odyssey to Mars.